Digital issuance doesn't become operational just because tokens exist. It works when blockchain connects cleanly to banking, custody, compliance, identity, and reporting. In this section, we'll focus on the integration layer that turns smart contracts into production-ready enterprise capabilities. So far, we've built the main pieces: the issuance landscape, platform choices, token models, smart contracts, stablecoin settlement, custody, wallets, and compliance controls. Module 7 brings those pieces together into an operating enterprise architecture. The focus is integration: APIs, workflow engines, reporting, treasury links, compliance systems, and custody processes working together so a regulated institution can issue, settle, safeguard, monitor, and report digital assets reliably. An issuance platform creates business value only when it connects with the enterprise around it. Customer records, payment accounts, custody, compliance checks, finance, and reporting all need trusted exchanges with the blockchain layer. Data, transactions, decisions, and audit evidence must move in controlled and traceable ways. When integration is weak, teams see breaks, mismatched reconciliations, compliance gaps, and poor user experiences. Strong architecture makes the platform reliable, secure, auditable, and scalable. A useful way to think about integration is as layers with clear responsibilities. User channels should not talk directly to blockchain or core systems. They go through controlled APIs, orchestration, and integration services. Blockchain access is isolated through nodes, RPC providers, event listeners, and indexers. Enterprise systems connect through secure APIs, queues, files, and event streams. This separation makes the platform easier to secure, monitor, change, and govern as products, users, and regulatory requirements grow. APIs are the front door to an issuance platform. REST is usually best for clear transactional actions, such as onboarding, issuance, transfers, and settlement checks. GraphQL is useful when users need flexible views across portfolios, dashboards, or reports. The gateway becomes the control point, authenticating, authorizing, throttling, validating requests, routing traffic, and recording audit evidence. In regulated integrations, versioning and contract governance are essential. They keep banks, custodians, and compliance vendors aligned as services evolve. Many digital asset workflows do not finish in one step. A transfer, KYC approval, settlement, or token issuance may emit an event, and other systems react when ready. Webhooks work well for vendor callbacks. Kafka supports high-volume streams, audit trails, analytics, and replay. RabbitMQ fits internal task queues and dependable work delivery. The key is disciplined event design: schemas, correlation IDs, idempotency, retries, dead letter queues, and monitoring. That discipline makes failures recoverable instead of mysterious. Production blockchain integration is more than calling a smart contract. Applications connect through managed or self-hosted nodes to submit transactions and query state. Listeners then watch emitted events, such as transfers, issuance, freezes, redemptions, or settlement. Indexers turn those raw events into normalized, searchable records for enterprise systems. The critical engineering work is reliability: confirmations, finality thresholds, duplicate handling, reorg recovery, and durable storage, so downstream applications see a trustworthy version of on-chain activity. Choosing an integration pattern starts with two questions: who is waiting, and who must control the outcome? Synchronous APIs fit user-facing moments where an immediate answer matters, such as eligibility or submission. Asynchronous events fit slower trust boundaries, including blockchain confirmation or compliance approval. Orchestration is best when one workflow must coordinate steps and rollbacks. Choreography works when services can react independently. It reduces coupling, but it also requires strong event governance. Identity integration goes beyond single sign-on. The platform has to connect who the user is, which legal entity they represent, what role they have, and which wallets and blockchain addresses they may use. Standards such as SAML, OAuth 2.0, and OpenID Connect handle authentication. Authorization comes from mapped roles, accounts, and permissions. Compliance adds another layer by linking KYC, KYB, and investor classification to whether a token transfer is allowed. Custody integration acts as the control layer between the issuance platform and institutional wallets. A transaction request first passes policy checks, such as limits, whitelisted addresses, and segregation of duties. Required approvers then authorize or reject it. If approved, the custody system signs through MPC, HSM, multisig, or a smart wallet. The transaction is broadcast, confirmations are tracked, and webhooks update the platform. Every step needs audit logs, alerts, exception handling, and clear operating runbooks. Payment integration is where digital asset workflows meet real money movement. Funding may arrive through wires, ACH, SEPA, faster payments, or local real-time rails. The platform should not issue, redeem, pay coupons, or settle until payment status is confirmed and reflected in the treasury ledger. Stablecoins can speed up settlement, but they still need reconciliation against fiat accounts. Strong designs account for cutoff times, failed payments, liquidity gaps, bank statements, and exception queues. Tokenization becomes institutional when it plugs into the systems teams already use. A subscription may start in CRM, where the investor relationship and onboarding status are tracked. The portal captures the order and exposes documents. Workflow routes compliance approvals and exceptions. Once payment is confirmed, tokens can be issued, while ERP records fees, tax, revenue, and accounting entries. The result is not just a blockchain event. It is an end-to-end operating process with auditability and reporting. Compliance architecture is only as strong as the systems it connects to. Identity checks, sanctions screening, wallet monitoring, and transaction surveillance must feed clear status back into token controls. Before issuance, transfer, redemption, or secondary trading, the platform should verify current compliance results. Reporting matters just as much. Regulators, auditors, tax teams, and risk teams need consistent records. Every decision should be explainable, versioned, and tied to the business event it influenced. In production, the blockchain is only one record of truth. Off-chain databases manage identities, workflows, documents, and permissions. Internal ledgers track balances, obligations, fees, and settlement events. Blockchain indexes normalize on-chain activity, so teams can search, monitor, and report. Reconciliation then compares these records with custody and bank data. The goal is not perfect duplication. It is controlled consistency, catching breaks quickly, explaining them clearly, and proving the platform's books match reality. The key takeaway is that tokenized platforms succeed when blockchain components are connected to institutional operating systems through disciplined integration. APIs, events, listeners, ledgers, and reconciliation controls create reliability and auditability. Next, we shift from architecture design to DevOps, deployment, production readiness, and the final capstone decisions.